Alright, so now comes the trickier part of this the section of this part. So a boring or drilling into the ground examines the friction on the slope below the house and finds that the friction is 17,000 pounds. Draw this force into the pictures above. So these guys up here, friction force again is opposite direction as the gravitational downslope force. They're going to be 17,000 pounds, which equals however many millimeters you think correspond given all the work that we did here. Okay, and then label each figure as stable, unstable, or just about to slide. So remember that stable means that the friction force equals the gravitational downslope force. Unstable is that the friction force is less than the gravitational downslope force, and and just about to slide, it means that they're the same. I think stable, I said the opposite. Stable should be friction force is greater than gravitational downslope force. Okay, there you go. Okay, so number 7. A developer buys a plot of land with a 25-degree slope. The friction in the slope is measured at 60,000 pounds. So draw a diagram of this scenario below and figure out what the maximum weight a house can be on this property. So, fair warning, here's where you're going to need the protractor to measure that 25-degree slope. And another thing is that this space that I gave you is probably not going to be big enough. So you might want to bring out an extra piece of paper so that you can actually give yourself enough room to draw the slope, the house, and the different vectors that you need. Okay? So I'm going to help you a little bit with this. Alright? Alright, so what I have here is kind of a setup so that this would be what you are drawing on that space. So I have some sort of slope. I haven't measured it yet, so that's what I'm going to do with this protractor. So let's see. So you place the edge of it on the middle of the protractor. Maybe center it right. Sorry, my thing is being weird. Alright, that works. And then you want the slope to actually be at 25 degrees. This is at 10 degrees as you're seeing in the protractor. So you want it to be at 25 degrees. Excellent. Okay, so that should be your slope. Now we can get rid of this protractor. You place your house on the slope, right? And then you know that the gravitational downslope force is going to be parallel to the slope. We should probably make it just on the slope first before we place it above, so we know that it's exactly parallel. Okay. And then we move it. So we know that this is the direction of it. We don't know how long it's going to be yet. And then we need to make a gravitational perpendicular force. So remember, perpendicular means that it has to be at a right angle from the slope itself. So that's why I have this box here. So I'm going to place the box against the slope, just like that. And this arrow is going to come in that direction. So I don't know again what lengths they're going to be yet. I just want to get the directions right for now. Excellent. And you know that gravity is going to be simply pointing downwards. So as downwards from or as parallel to the edge of your paper as possible. So we can actually measure that, I suppose, against this edge. Yeah, it's perfect. Alright, so I'm going to put that black just to match the rest. Okay, so now, so we also know that there is a friction force being applied here, right? And we do actually know the length of the friction force, or we should be able to figure it out based on the different answers that we got from the previous questions. So we know that it's 60,000 pounds force. So given whatever you have measured each pound to be, you know how many millimeters that friction force should be. Okay, so I'm going to make the friction force red. Alright, so let's assume that that is that length. Remember that the problem, what it wants you to do is find how heavy the house can be, okay? And remember that in previous exercises, how heavy the house can be was the same amount of pounds that the gravity force was, okay? So however long this is correspondent to some weight, or that the force basically can handle. And so that means that a house, however heavy, can actually withstand, or can actually stand, I should say, in this slope. So, and it's asking you for the maximum weight of the house in the slope, meaning that the house cannot be stable, it shouldn't be stable, nor should be unstable. It should be just about to slide, which also means that the friction length should be equivalent to the gravitational downslope length vector. So in truth, I don't know again how long these are. You'll have to figure that out based on the friction force length. But in truth, these two vectors should be the same length, the same magnitude. Okay. Excellent. So figuring this other two vectors length is relatively easy, as you have done in the previous diagrams. So I will let you handle the rest of this problem. I think you can do it. The answers on the quiz online should be straightforward. There are some that are way too low and some that are way too high. So hopefully you will get the correct answer, or near enough what is there online for you to choose from. Okay, so once you have finished this second part, you can move on to the third part. This is much easier, I think, and you won't need my help very much, but I still want to point out a few things from the map. So this third part is called Relating to Landslide Hazards in Idaho itself. So you'll need two different PDFs that I also attached in Blackboard. One is a landslide hazard in Idaho pamphlet, which is this one. So this is how it should look. And there's just some information there for you to read and be able to answer these questions. And then the second one is the Surficial Geologic Map of the Lewiston area, which is also attached on Blackboard. I recommend that you do not print this map because it's going to be tiny, but that you manipulate it on a PDF and just zoom in and out as you need to, just like I'm doing. It's going to be much, much easier. Okay, so questions 8 and 9, you basically get from the pamphlet. So I'm going to go ahead and let you read through those and answer that accordingly. All right, and so now let's go ahead and I'll help you out with this bit just a little bit. So basically now we're going to be using the Surficial Geologic Map of the Lewiston, Idaho area. You can read through that. And let's get to the question. So question 10. What do the red arrows symbolize? So if we go to the map itself, it's hard to see obviously when it's this small, but once you zoom in, you'll see that there are tons of red arrows throughout the whole map. So if you know how to read topographic maps, you may already know just from what you're seeing right now what these arrows might mean. But if you don't, you might be a little bit more confused. So most maps have a legend of some sort. So legends tend to be on the right side of the map or on the bottom side of the map or something along those lines. So in this case, there's a huge legend to the right side of the map. And in the legend you can find things such as descriptions of the units that you find, the geologic units, so the different colors and symbols and patterns that they are attached to. But you can also find, for example, symbols. So the red arrows are a type of symbol that we have, and it's going to be here. So hard to see, again, you have to zoom in quite a bit in order to find the red arrow symbol and what it means, but it's there on the legend. Excellent. Now, question 11. What do the red lines with the tick marks, which look like homes kind of, symbolize? So let me show you those in the map first. So what they mean by the red lines with the tick marks is these guys right here. So this kind of looks like a comb, sort of. So red line with tick marks. There's all along this scarp here, and there are going to be some individual ones kind of scattered throughout. So for example, there's one here, so on and so forth. And so we still don't know what that means unless you're really good at reading maps, which I don't think many of you are, but maybe you are. So you go to the symbols again, to that legend part. And luckily, we also have a symbol for that, or an explanation to the symbol. So there you go. Oh, sorry. Excellent. So now, what does QLS indicate? So when they mean QLS in this case, they mean one of these symbols, if you would, for the different formations, the different geologic formations that make up the map. So first you got to look at the map and find a QLS. So the QLS lies in this kind of tan color with red triangles. So now that we know what that looks like, we can look it up in the legend. So description of map units, that's what we want, but we want to find QLS, which is again tan with red triangles. So this is tan with green or red circles. Here's QLS with tan and red triangles. So you can go ahead and respond to that question once you find it. Okay. Alright, I'm going to go ahead and let you finish these other ones on your own. And I think that should be enough to give you a very good head start on the whole lab. Again, the hardest part is going to be part 2, I believe, for most of you. If you need help, definitely let me know. But I think this video is definitely going to be a big help. So good luck, and come to me if you have any questions.